In this episode of the Data Exchange, I speak with Denise Gosnell, Chief Data Officer at DataStax. Denise is also the co-author of the new book, The Practitioner's Guide to Graph Data. This book covers foundational tools and techniques needed to utilize graph technologies in production applications. All right, so Denise Gosnell, Chief Data Officer at DataStax and co-author of a new book from O'Reilly called The Practitioner's Guide to Graph Data. Welcome to the Data Exchange podcast.
Yes, thank you so much, Ben, for hosting me. I'm really looking forward to this conversation.
All right, so I think just for our listeners to kind of put everything in context, let's start at the very basic.
That's a good idea.
When you say graph data, what do you mean?
I definitely do not mean a bar chart or a pie graph. I mean connected data. So we're talking about vertices and edges or dots and lines and thinking about how information is connected. So if it's new to you, I would think first, if you are on social media, you have your profile and you're always probably looking for those mutual connections, right? So you find someone and you look at your mutual connections to build up a story maybe about how you know them. And when you're doing that, you're thinking about data like it's connected. You're trying to understand yourself and how you're connected to somebody else. And that's what graph data is: connections between information, people, places, things, stuff like that.
So a typical data scientist, they tend to work on structured data, text, increasingly images, but graphs. I think the people that you describe who work at social media companies, they do work on graphs, but it's not a typical data set that an average data scientist works on day to day, correct?
Correct. It's I would call it an emerging shape. So when you're a data scientist and you're thinking about all the skills that you need to sharpen in order to be a modern data scientist, absolutely, nested data, JSON, NLP, those types of processes are all required for your modern skill set. And we're starting to see this emergence of a new shape of data, namely connected data, graph-shaped data, being the new tool you need to have in your arsenal for being able to work across a whole myriad of applications.
So to our data scientists, data engineers listening to this, so make the case for why should they add graphs to their toolbox. What's compelling about graphs? Can I get jobs if I sharpen my skills on graphs?
I mean, you definitely can get jobs, but the case for learning graph data is that it's the layer underneath that provides deep insight into the analytic that we've all become used to understanding. So when we have the traditional evolution from business intelligence to data science, we're traditionally still working in feature tables, primarily flat sets of statistics and information. But when you really want to dive in and understand the underlying behaviors that are driving those changes, or maybe driving slight adjustments in your feature table, it's usually coming from connected data or connected behaviors that are existing across your system. So it's a natural evolution that we're seeing a lot of modern companies start to take from their research departments and then put into production for being able to derive more value and really explain the reason behind an insight or a feature.
So I'm in a company, we start accumulating graph data. I try to attack it using my standard tools and techniques. So where do I hit a wall? When do I hit a wall?
So I think we also want to start with what are the standard techniques, right? Yeah. And then absolutely, Ben, where do you hit a wall? The natural evolution right now with graph data starts primarily in graph algorithms and just trying to understand the connectedness of your data. And if you find an important pattern, you'll see that emerge to become, say, a database schema for doing something transactional within your production application. So that, like, kind of thinking through NetworkX or GraphX and the algorithm space that you have across your famous and popular libraries, then moving into the graph database space for actual online transactional databases. That's kind of like the trend of the tools right now. And yes, absolutely, it's a great question. You hit different walls along the way, and it really depends what you're doing. When you're working within the graph algorithm space and you're trying to do global computations across the entire connectedness of your data, you're likely going to quickly run into a wall on CPU or just overall RAM for being able to process that much information. And typically that's
RAM is cheap now.
RAM is cheap, as is disk space.
Yeah.
It's all cheap.
SSDs, right? So SSDs are plenty fast.
And using GPUs as well, because behind a graph, we just have a matrix. So using a GPU for processing is always a great idea.
By the way, at the risk of dating myself, the first generation of graph tools I started to investigate was in the Graph Lab Giraffe
Yep.
era, right? So
it's still around. I don't know if you're dating yourself yet too far back. So I'm sure there's other references that you could throw to that really would, but I wouldn't call that one.
So, but Denise, those tools, particularly the Giraffe scale tool, I mean, do I really need that? Because I'm just a regular company. I'm not Facebook.
It depends on what you're doing, but I would say for the regular company, the majority of problems that you're running into are just trying to understand if or why connected information is meaningful to your problem. And you're typically just going to look at wanting an algorithm a library of algorithms to run across your global structure. People will write doubly linked lists and do this on their own as well. You don't necessarily always need a tool to solve it, because the idea of doing breadth first search or depth first search is a fundamental thing that all computer scientists are taught.
So let's translate those algorithms that you described into business problems. So
Okay.
What kinds of business problems are we talking about that would be a piece of cake to answer if you have the right graph algorithms?
So piece of cake to answer and right graph algorithms, two different things in our world. Yeah. So piece of cake to answer, I would say the business problem is converging to something called customer 360.
Okay.
In a graph database, I want to model my customer as a vertex label. And I have all of these tables or all these silos of information about my customer that are really important to my business. And I'm going to use a basic graph structure to model my customer and use edges to link them, say, to the stores they shop at or the different addresses in the system, products they purchase, things like that.
Sounds like a star schema to me.
It is. It's exactly a star schema. That's exactly what it is.
So why do I need a graph?
For getting into your graph algorithms, right? Okay. So to the second piece, that's actually, Ben, that's a really great point too. If you just need a star schema and you're not really going to go any deeper, it's not necessarily a great place to just throw graph technology into your stack, because you're bringing in a hammer that's way too big for your problem. But I see companies start there. Many companies that I work with around the world, they'll start with these basic star schemas because they want to ask the higher valued graph algorithmic questions, like betweenness centrality, or which is just trying to figure out how important or how connected things are across this massive structure you're building. Page rank, very, very, very popular for wanting to understand across who is connected to who, what's most popular, what's not trending, things like that. That's why you start with the star schema, because then it makes it really easy to do those deeper questions once you want to get there.
So I imagine if I'm in a company, we have a data warehouse, someone put in the time to design a star schema. Mm-hmm. I start putting up dashboards, and then I encounter one of these questions that you describe. Mm-hmm. My initial instinct would be to try to just power through using traditional relational techniques, right? So again, going back to my question, so why won't that work?
So you're going to hit a wall there too, and maybe it's just going to be a wall of stamina. That might be what it comes down to. But the wall that I see hit there is the wall of recursion. Because typically the first thing that you want to answer once you connect everything together is, well, all right, for any two things that I care about, tell me how they're connected. I don't know the path. I don't know which join tables you want to walk through, but I want you to tell me the answer. And it's the expressiveness and the ease of writing with graph query languages that enable that to be possible. Because we're looking at, statements in graph query languages that are saying, from this person, keep walking through all my edges until you get here. And the code really does pretty much follow like I just spoke about it in language. Whereas you have to be much more explicit about which tables to walk through when you're using SQL or other relational style languages. So it's
So these graph query language are declarative, and they're very human readable, right? So, I admit, Denise, I haven't been paying attention to the specific types of graph query languages, but I know you folks at DataStax have a horse in the race. But
We do, yeah.
set that aside. So, what are the top graph query languages? So, what is the PyTorch, TensorFlow, so on and
Yeah,
so forth?
that's a great question. And so when we're talking graph query languages, also to kind of orient people who are trying to understand all the technologies, we're kind of now solely looking at, I have a graph database. I have stored data in that database and I'm trying to, retrieve it. That's much different than the world of graph algorithms that you do have Python libraries for. So in the world of graph query languages, you have your common players like Cypher, Gremlin, which is the one that DataStax is the primary sponsor behind. You've got GQL, the graph query language, which was an emergent standard language that they're creating. You have Sparkle, which is an RDF query language for doing semantic triples. That one's the longest graph query language that's been around that has a WC3 standard around it. And there's a myriad of others. And when it comes to graph query languages,
so there's no dominant one.
Yes, yeah, that's what I was going to say. I would say that taking off the hat that I wear for my daily employer, there's not one graph query language that is ruling it all for all of the graph database implementations. You have the query language that is implemented by every graph database, and you also have the query languages that are most popular when you search the web, and those are two different languages. But the main wall that we're hitting right now with the graph query language space is the difference in thinking that you have to apply. And that's why after all these years, we don't have the graph community saying that this one language is going to rule them all. We've been asking technologists now, instead of thinking in tables, we're primarily thinking about relationships and connectedness. And it's bringing a whole new functional paradigm to how you think. Not only are you thinking in graphs, but now you're thinking in streams of data as you're walking through your graph database. And there's just a lot that has to occur in order to use your data in that fashion. So, I mean, I have my preferred language. Others have their preferred languages. And to me, the bet is still out on how we're going to move forward as a community.
So when I think of graphs, and I guess just data in general, and I want to do something with this data, there's kind of these buckets, right? So there's, like you said, the models, algorithms. There's analytics, which is the reporting. There's search. And then there's the OLTP kind of system. And years ago, actually, Denise, I had Emil Ephraim on my old podcast when I was still at O'Reilly. And I was surprised, actually, when he said that for them at that time, and I'd have to check how many years ago this was, that many of their use cases were in the OLTP space, not anywhere else. So break down for us kind of the different. How do you organize the graph space in your head?
I mean, honestly, Ben, I think you organized it for me. That was, I do see it in the world of, OLTP and then OLAP, but I'll just think of algorithms really there. Those two worlds are primarily where people are working today.
So explain to people, what is the application of graph technologies in transactions, OLTP?
I love that question. And Ben, I love that question the most because I feel like we're starting to actually see a convergence to schema and kind of database architectural patterns in that space. Because to Emil's point, which was probably about 10, 12 years ago at this time, people were starting to pick up graph data and put it into a transactional database for more real-time applications. And over the past 10 years, we've seen a convergence to patterns of how people are using it. I see 4 primarily ones, and then you kind of open up to a whole world of the long tail distribution of random applications. But those 4, the first one were Customer 360. So the 4 patterns are Customer 360, hierarchical data or trees, pathfinding, and then the recommendations bucket, which is probably where the data science audience is most familiar with the Netflix prize of recommendations.
What about the one that I also hear a lot about is fraud detection?
And so that's a fascinating one. From my perspective, fraud detection is going to be an outlier in one of those four models.
I see.
So you're going to, if we stick with the STAR schema, because mentally that's the easiest one to think about, a customer, information about your customer. Maybe your data science team has learned a certain emergent behavior about customers where it's fraudulent if they are, primarily a in-store purchase customer, and then they have 6 online transactions in a row. I'm totally making that up. But my point here is that for a star-based schema, being able to detect that in a graph for fraud detection can be done near real time. And that's going to be a different application of fraud detection than, say, pathfinding, which is something that we do for governments around the world, where pathfinding now is not just based on that star, but it's based on the distance between 2 points or 2 people.
Contact tracing.
And contact tracing now. So we have contact tracing as an emergent need that I have seen a ton of fantastic community contributors actually open sourcing graph-based applications for contact tracing.
So where are we now, Denise, in terms of compared to 5 years ago? Do you feel like when you go talk to an enterprise or a company, a government agency, do you still need to educate them on graphs?
We do. Graph technology really has not crossed the chasm of it being something that everyone understands. So we do still need to talk about why connected data is important. We still haven't, there is no answer to the language war that's still happening. And where I also think we are, as I mentioned, is we're starting to converge on, database schema and OLTP common patterns of how people are implementing these applications in a database.
So I'm a CIO. One of my architects says, let's bring Denise and her team in, and we'll bring in their graph database. And then my reaction will be, do we need a specialized system? Right. So our infrastructure is complicated. So now you're bringing another piece of infrastructure, and it's probably another one of these distributed systems, adding complexity, training, maintenance, and so on and so forth. So why can't I just get by with a general purpose system?
I love this question. It's one of my favorite conversations to have with CIOs, and it just, there's so many levers behind that question, Ben. But from my perspective, it's about the natural evolution of what CIOs are trying to do with their data. The data lake is there, right? Everyone has their data lake. Most modern CIOs now have their Delta Lake, and now everyone's
lake house.
Yeah. and
I'm part of the crew that coined the term. Yeah.
I love it. It's a good one. And I, at this point, they're really wanting, to your point, they don't want an extra system. They want to put that mesh connection on top of their data lake, so they're just understanding within their existing system what's already connected.
Or what is that? What's the term that Arango DB uses? Multimodal?
Multimodal, yeah.
Multimodal, yeah.
Multimodal, yeah. So it depends on where you are on that journey, right? So if you are brand new, CIOs are picking up stacks that are multimodal. Thanks for that. That was great.
Or Stonebreaker has this thing where, if you have a general system, I guess it's, I don't know the exact term he used, but basically it's crappy at everything.
Oh, right. Like the common adage that to say that you're good at everything means you are also terrible at everything. No, I know what you mean by that. But yes, so I'm seeing CIOs go after a technology solution that's going to provide multiple layers, because to the very, very first topic we talked about, you still need to have a solid solution for search, for doing character edit distance and then predictability on your search results. That still has to be just as good, because we are all very spoiled to using Google search these days. We can't pick up a new stack and that problem not come with it or be well solved with that stack. So.
And so graphs, just like any kind of data, at some point there will be applications that require real time, right? So where are we in terms of graphs and real time applications?
I think you use them already. Yeah. No, and I say that just kind of jokingly, especially given the state of the world we're in, because the streaming applications for watching media, they have probably seen a lot more load recently, and Netflix is the one I'm thinking of in my mind. And
No, but
the
the question there, Denise, is are they actually using a graph system, or are
Mhm.
they getting by with something else?
I can't comment specifically on Netflix, but I can comment on how they would do it if they were doing it in real time.
Okay.
And that recommendation window is what I'm referencing. There is the nuance behind that is a very detailed question that I know you can see. So here's what I see. We're using applications and we're clicking on recommendations. That isn't going to be a real-time recommendation across your entire global graph structure. But what they have done is they have two systems. They have one that is doing your batch process, learning that recommendation using connected data. And if they're smart, which a lot of the customers I've been working with are doing this pattern, you learn the deeper traversal and then you store it in what we call a shortcut edge. So in your real-time application, you are using graph data. You're probably just not walking beyond that star. So most real-time applications that are using graph data are staying within the stars for doing real-time lookups, like customers or companies who dynamically render web pages according to content recommendations. But that's usually and most commonly backed by a longer running analytics process that does the update through a deeper graph walk, many edges, and then you store a shortcut for that star real-time traversal.
You know, the company actually, as you were talking there, the company that I don't think a lot of people realize has some of the most challenging graph problems and also have to do it in real time is Pinterest.
Yes,
Yeah, because
yes.
I forget exactly. It's something to do with the boards, makes it a lot more complex problem.
Yeah, and I think a company like Pinterest is really good to think about because once you walk through their data, you can see many parallels in other systems. So Pinterest has boards, which has pins. Those boards are owned by your profile, and they're also shared. So now you already have a very, very, very fascinating network of boards by profiles, and then a nested dependency between boards, other boards, and pins, but they can be pinned elsewhere. So following that network is very, very fascinating. And walking through it deeply is how you learn offline new pins to recommend. But to your point, Ben, they're not gonna on that recommendation walk through that full structure real time. There's no way all of the data required to provide that can be done within a web page SLA.
So you look at other data types, so starting with computer vision and speech and now
Mhm.
text, deep learning has kind of disrupted what people are doing. And then to some extent, less so, less clear that they can dominate is in structured data. I mean, people use deep learning in conjunction with other things for time
Mhm.
series, for example.
Yep.
But the last few years, I'm starting to read papers about graphs and deep learning. So where are we in terms of how dominant is deep learning when it comes to graph and graph algorithms?
It's at its infancy stage, and I think that the most popular work that you'll be able to find out there, you've stumbled on, I'm sure, is just graph embeddings, and we see some interesting work coming out of Facebook on how to use graph embeddings. But when it comes to the intersection between graph structured data and deep learning, I'm much more interested in seeing the future of reinforcement learning being used to update the speed of our deep graph traversals. And here's what I see. So when we're working within reinforcement learning, we're semi-supervised, kind of exploring structure. I typically was working with this when I was doing maze finding, just the canonical way you start with reinforcement learning. And once you find a goal, you're able to update state in like a descending fashion after you've reached your goal. And every time we've been working with people using pathfinding applications, I see a very similar parallel between how you use eligibility traces from reinforcement learning to update state in a dynamic environment in the exact same way that you would be using the path to a destination to update state for a graph structure. And what I see
So
is that
what are some use cases for what you're describing?
so the use case for this actually is used by many governments already around the world. Whenever you scan a passport at a border, there's going to be a back office that's looking to understand how you are potentially connected to, say, a known list of people that they're concerned about. This is done all over the world today with graph technology. And what I see, though, in the common structures of graph data, you end up with a highway or a backbone that the graph community likes to call, which is just as you would think of it. It's going to be the highest throughput area where most paths travel through a few connections in order to get somewhere else in your graph.
This is always the case with graphs, by the way.
It is. Yeah, right. They converge. They converge
Yeah,
to this backbone structure, which is going to be a scale-free connected network where, most vertices have a very few number of edges, and there's a very few vertices that are highly connected to everything else.
And then back in the day, companies like Twitter, once they realized this, they would just optimize the hell out of those backbones. Yeah.
Yes, they would. And getting to the backbone faster is where I see reinforcement learning coming into play, because these pathfinding applications, which is basically the next step you go after the star schema that we've been talking about, you now want to know, well, for any two people, tell me the path. Using eligibility traces and deep learning from reinforcement learning will give you the ability to converge to your backbone or converge to this highway system much faster, from being able to upweight certain edges for being discovered on a path and things like that. So to your question, Ben, about where we are in the intersection of deep learning and graph technology, we're at the very beginning, and I do see that some of the emergent work that could come out would be in that space, the intersection of eligibility traces, reinforcement learning, and evolving graph structure.
So for reinforcement learning, I have a library for you, which is probably the most popular open source library, RLlib.
Yes.
From Ray. Yeah. I don't know if you guys have played with that. By the way, so in the rest of data science and machine learning, Python now dominates.
Absolutely.
So what about in graphs?
And from what perspective do you mean?
So just are all the tools friendly to Python, the people who use Python?
I honestly think that Python's going to be the most transferable language across the journey that we've been talking about, right? Because we know the journey is going to be from graph algorithms moving into graph tools and graph databases. And Python is the ubiquitous language for being able to work with all of those.
But I don't need to install, and I don't need to have the right version of the JVM, do I, to install any of these tools?
No. Well, for some of the tools, yes, but the ones that I'm referencing, I do like to stay just within the Python stack.
And so are there graph applications for, so nowadays you also hear about, even in the machine learning and deep learning space, they need to make sure that their algorithms and models run on mobile devices and edge devices. But graphs, if your graph is humongous, how can you even shrink it to fit into one of these devices?
That's a really, really great question. The intersection of graph structured data and edge computing, is not something I think I've explored fully, where if you think about what you could have on a mobile device for the most common ways that companies are picking up graph technology, which is for that star schema. I mean, you can locally persist essentially the customer in like a few neighborhoods out, where we're now just talking about partitioning your graph into smaller sections so that you can have more localized traversals. But that's all going to be custom and application specific. There's not really a modern and agreed upon approach on how to do this yet. Probably because it's really just being worked on within the larger distributed data community and solutions for doing distributed databases.
And so are there specific applications of machine learning to graph data that you think is underappreciated?
Machine learning to graph data that I think is underappreciated. That's a really good question. I mean, personally, I don't know if you would consider the reinforcement learning example to be that bucket.
Yeah.
Because I personally think that's one thing that is yet to see enough exploration. So that's my first go-to answer, which is why aren't people using that?
Or even search rankings of the flavor of PageRank. Right?
Yeah, I mean, can we say that's underappreciated though? Because it's basically how PageRank is working now.
Well, so, I think underappreciated in the sense that your typical person won't know how to do it, even a data scientist, right? So.
I got it. I know. I understand what you mean now. And then absolutely, in the idea of underappreciated because they don't realize that graphs are being used. PageRank definitely takes the cake. Everyone is, going to their various search algorithms or search portals every day and searching for content. And the linking graph of what pages link to what is absolutely how those results are returned. And people have no idea that that's what's happening.
And being able to do it fast.
Mm-hmm.
And actually, I had a guest recently on the podcast earlier this year, IDO Liberty, who came out of Amazon AWS Research. So
Mm-hmm.
he's building a startup that's basically focused on productionizing machine learning for search applications. So it's because it's very specific that you have to be very responsive. You have to provide people with the right choices, and then a lot of companies, it's a bit too complex for them to do all of this and be able to do it in production. So a lot of companies, as you can imagine, Denise, they have data scientists who are good at the modeling part, but then how do you productionize that, right?
That absolutely. That is a really, really large underappreciated skill set for the modern data scientist. And I've seen way too many projects, both in data science and in graph technology, get shelved and never see the light of day because of the lack of skills of understanding what it takes to get a model, be it machine learning or graph, into a production application. Because in my perspective, we're so spoiled these days. We have so many well-run, seamless applications. So the bar is just getting ever higher and higher for the next idea that you're wanting to build. And I think that kind of ties in, as I was thinking back to your other question about underappreciated applications of graph. We kind of talked about it at the beginning, but I think the most underappreciated, but also used everyday application of graph is that mutual friends section of any social media site, or even that badge that LinkedIn has of how connected you are to somebody else, the first degree, second degree, third degree. That's the beauty of graph technology from my perspective. We use these things on our applications already. They're inherently a graph, they're graph structured problems behind it, but they're so intuitive to understand that we don't really think about how they were computed or how they're delivered in an application with millisecond SLAs. And that really, I think, is the beauty of graph technology. It is underappreciated because it's so natural for people to understand why it's important.
So would you consider, Denise, the area of knowledge bases in this as part of graphs? Do you consider?
The knowledge bases, as in knowledge graphs?
Yeah.
Absolutely. I think that's also the idea of knowledge bases and knowledge graphs is the emerging behemoth, I would say, of like a big graph use case. My caution there, though, is that whenever I see people in the world of knowledge graphs, knowledge bases, they're following the trend like we talked about earlier, data lake, delta lake, give me a data mesh. This whole idea of a data mesh is very similar to a knowledge graph, a knowledge base. Everything's all connected. And the caution is that there's the lack of specificity. There's a lack of direction of like exactly what you're looking for in that connected set of data. So when you go about it, of course, if it's important, go ahead and build out your knowledge graph. But think about, at the end of the day, what API you're going to be deploying, what query you have to ensure meets an SLA, and set up your knowledge graph to be able to meet those standards and get one small piece all the way through to a production API so that you can understand that end-to-end process, just like we were talking about with data science or machine learning projects never seeing the light of day, because DevOps skills and deployment are extremely important.
And the knowledge base folks too, they seem to be in their own sub-community, right? They have their own conferences.
They do, yes.
Yeah. And so they're a bit detached from just data.
And it's weird that it has evolved this way, but here's the reason why. Within the graph technology space, you have a subdivision of property graphs and then RDF or triples. And at the end of the day, we're still modeling the connections and the relationships between things, but the technologies and approaches have just kind of diverged into two different streams of technology. And I've had some excellent conversation with different people in the community trying to find ways to bring them back together, because at the end of the day, we're all doing the same, very similar things, very similar patterns of queries and data models, et cetera. But that's what's happening that you're commenting on, Ben. You've got the the RDF and semantic web community that's been
Yeah,
around
yeah.
much longer.
Right,
And
right.
then the emergent property graph community that's kind of more 10, 12 years old now.
Who actually have things in production.
Yes. Yes.
So,
Nice
so,
jab.
so you just you co-authored a book called The Practitioner's Guide to Graph Data, but
Yes.
earlier in the conversation you admitted there's not even a accepted query language. So, what could be in the Practitioner Guide?
So the practitioner's guide, I love it, Ben. I love it. So the practitioner's guide teaches the query language that's implemented by every single graph database.
Okay.
It
Which
also, which is Gremlin, Apache
okay.
Tinkerpup Gremlin.
Okay. Oh yeah.
It also happens to be
Matthias is
Emil and Marco Rodriguez.
okay.
Marco Rodriguez is the main brain behind Apache Tinkerpup Gremlin, and Marco Rodriguez and Matthias Broschela came together to form Aurelius, a company with a graph database query language, and then a pluggable.
Which was acquired by DataStax.
Yes, acquired by DataStax. Yep, that's a short path on how I got here.
And is the graph database inside DataStax? That's not open source, right?
It is not open source. It was open source with Titan, and so now it is a distributed adjacency list within Apache Cassandra. So it's just a native implementation of adjacency lists in Cassandra. But we are taking a big step back towards the open source community that I'm sure a lot of people have noticed, because that absolutely is where, as a company, we know that we want to and we are ready to be.
So so actually, as you were talking, I just realized the region of the world where I really see massive graphs, because I helped organize conferences there over the last 5 years, is China.
Yes, absolutely.
Yeah. And they either have their own homegrown technology, or for the most part homegrown, or there are companies that are selling to the Chinese companies. Like there's actually a company out here that I know called Tiger Graph.
Yes.
Yeah. So they have a lot of I think users in China, but I would imagine India too would have massive graphs, right? Because the number of users of a company there. So anytime a company has a lot of users, chances are their graph will be massive, right?
Yeah. Yes. There's a high chance, a high probability there. And I do have. I'm trying to think now back to the different users who have reached out to me in conversations with this book. I would say that disproportionately geographically, we've had a lot of readers, a lot of participation in social media conversation from developers in India. And I also see, I would say the third hottest region right now, this is quite a large region, but Eastern Europe is also really picking up in their use of graph technology. Fascinating. I kind of want to go see what's going on over there.
So like I said, so earlier on in the conversation, I alluded to the fact that while your typical data scientist is comfortable with structured data, text, and to some extent now even images, graphs, they're not as comfortable. So what would it, I think in my mind, the way data scientists get excited about something is, one, they hear about tech companies doing something interesting with graphs, which we all do, we all know they do. And then you have to have like a set of open source technologies or tools, and then a set of tutorials that guide a developer to get started without getting into the weeds of the details. So I think we need a lot of these pieces still, right, for graphs?
We do, because across the graph vendors and the commercial graph space, you don't have a lot of open source support yet. And there's fantastic tutorials. I will say that I think that Neo4j has done some of the best work in educating developers to understanding how to apply graphs. So if your audience hasn't checked out their work, I highly recommend it. They do some fantastic, zero to hello world style examples. And you got to give credit where it's due. They have some great work. From an open source perspective, I still have two favorite homes that have I always go to for just like the latest and greatest. It's been Snap and Kaggle. So Snap is the Stanford Network Analytics Project. They have open source data sets and
Jury Leskovich.
yes,
Yeah, yeah, yeah.
yes, yep. They've got tons of graph structured data sets and even like a graph data generator if you want to generate your own synthetic graphs. And it's a really great hub for anything related to the academic and open source, openly available graph community. And once you kind of explore there, graduate up to Kaggle. The Kaggle competitions and the notebooks are always fascinating. You can go back and look at like Facebook's triangle link prediction problem. There's movie recommendation examples out there, and get familiar with working with Python and the graph algorithms in a notebook environment and see what other people have done on Kaggle. Always a great resource.
And then I think there's enough data sets, right?
Yeah.
But there's no, Denise, is there the equivalent of ImageNet where people compete with each other?
For just graph
graphs?
algorithms?
Yeah.
We should go build it.
Yeah.
I don't think there's one yet.
Yeah. So there's no famous competition that people go to on a year-to-year annual basis, huh?
There honestly, Ben, there might be. And it's going to be one of those things where in 20 minutes, I remember it and I'm like, oh my gosh, I should have told you that. But off the top of my head, I can't think of one right now. Like the famous competition that really ignited the graph community was the Netflix prize, but that's 11 years ago now at this point.
Right.
But
and
for
then,
annual competitions, I'm drawing a blank.
That turned out to be easy to de-anonymize, and then 2, the winning algorithm was too complex to deploy to production.
Yeah.
So in your book, you introduced this concept called graph thinking.
Yes.
So explain to us, what is graph thinking?
It's what your brain already does every day. Graph thinking is just the natural way that you reason about the world according to how you connect to it. And then applying that same reasoning to your business's data. That's what graph thinking is. Nothing more complicated than that. I can imagine many of your listeners probably have been at a whiteboard and they may have been drawing different silos of data in their business. And I see this all the time. This is a pattern with tens and almost 100 teams I've worked with around the world, where you're drawing this silo of marketing data and then this silo of sales data, and here's your support data. And they don't really have a way to connect the journey of the customer from this part to this part to this part. And once you're kind of drawing that all out on a whiteboard, and you realize that the connectedness of your internal system and its complexity emulates your customer's experience with your brand, that entire process is what graph thinking really is about. And applying graph technology to simplify that so that your customer's experience with your brand is just as simple. The companies who are doing that are also the ones that are really taking off from an elevated brand and overall implementation and following perspective.
As you were talking there, I guess I realized, so one of the key differences with structured data is the regular business person uses it all the time with Excel and spreadsheets and things like that. So there is no equivalent of a spreadsheet or Excel for graph data, right?
There isn't, because if you tried, it would end up being it would be so immense that it would be really hard.
The user interface would be challenging. Now,
it'd be incredibly challenging.
There have been kind of these desktop tools that I've come across where you can do work with graph data and have cool graphs and things like this, but they're still somewhat specialized.
They are. That's a really great point. They're specialized to the vendor stack that they're with, and even in the book that you're referencing, it comes within this massive series of notebooks so that you can follow along and learn the business use case and learn the query language, but then also have that notebook experience kind of in your web browser to follow along, but then also view the graph data as you go. But to your point, Ben, it's still tied right now to a vendor specific lock-in. There are some open source tools that are emerging in different companies who are building vendor agnostic graph visualization, but it's still when you think about how easy it is for spreadsheets, it's not at that level yet.
So looking ahead, like 1 to 2 years, what do you think will happen to this tools in this space, and then just kind of the general acceptance and familiarity of not just data scientists but regular developers? Because I think the difference, Denise, is for machine learning, regular developers can now kind of get started, right?
They can. They
Yeah,
can.
yeah, yeah. So graphs, I'm not sure exactly where it's at.
Yeah. So, and Ben, when you asked that question, my mind immediately kind of went to three areas where I really am pushing for there to be more innovation: open source, query languages, and visualization. So in the next 2 years, I'm really looking forward to the reemergence of the open source community around Graph. It's been quiet for far too long, and I really want to see a big noise and splash come back. From a graph query language perspective, there's so much fascinating work that is being done with some of the smartest people in the world to come up with a more user-friendly or a more approachable way. Because to your point about machine learning, Ben, we don't have that low bar approach for getting started with graph query languages. Uh, I'm gonna put a heavy bet on seeing the emergence of GraphQL come together with graph query languages. It's already what devs are searching for, and the name is confusing people. So, we've been personally working on a way to bring together the most common graph queries into the GraphQL language. That's still kind of in R&D mode though over here. And then the third piece I see coming out, like you mentioned, is graph visualization. People want to see their data. Anytime I've ever worked with someone around the world, getting to see in their eyes when they first put some data into a database and get their graph visualization back out, it's empowering and it's fun. And I think we're going to see a lot more work come out in that space so that people can get more hands-on with the data, because we don't have the Excel or the spreadsheet version of graph structured data.
Yeah, actually, for example, when you look at a space like NLP, where there's been a lot of developments recently, particularly with these transformers and language models, the difference there is that now you have libraries, for example, in the open source, like Hugging Face, where they put all of the latest innovations that you read about into their library with the same APIs. So developers are using all of these things without much friction, number one.
Exactly.
And then I think also, I think what makes graphs hard is in the NLP case, I have a bunch of text. Okay, I'm ready to go. But with graphs, I imagine there's some pre-processing just to get your data into the format and into the schema that these tools are expecting, right? So
Yeah. Yeah, absolutely, Ben. And to me, the way when I hear you describe that, my brain sees it as the exact same problem as starting off on a brand new Earth and having to build roads everywhere. It makes so much sense that we have to build this connection to get around the land, but it takes a lot of planning to actually get that network in place. And whenever I've been trying to really fathom about the planning and the process around getting data structured like a graph, I see that as a very similar process as building roads for a new town. And all of the analogies on throughput and volume inside, they all kind of go in both of those stories. But that's kind of how I see the preparation playing out and how to kind of expect timing. And then that's not a good news then for more graph structured data, because I'm essentially making the argument that it kind of takes a while to think about it and restructure it. But that's what happens when you're trying to evolve human thought or evolve a new behavior. It takes a while to learn it and to think about it and to see it in a new structure.
yeah, and then as you said, a lot of companies already have domain knowledge. I mean, domain awareness that their data is highly connected,
Mm-hmm.
right? So, but then uh, they don't they don't necessarily want to have to think about or write special code to take data they already have to turn it into a format so that they can get started, right? So it's a lot of that you folks should make it easy, right? So here's
Or
the data, there's connections in here.
yeah,
Your tools will discover and then encode it into in the right way, right?
I agree with you,
Yeah,
but I would also then question
right.
if we have just started with the wrong shape of data to begin with.
Oh, okay.
So
Tables are great.
maybe we started at tables and we shouldn't have started there. I mean, because I don't know, if you're trying to list out your family or you're trying to list out anything that's important about you as a person, you're going to draw a tree, you're going to draw a network. And every human on this planet thinks that way. But we've now shoved all of our brains into thinking in rows and columns. So going back to our natural way that we perceive the world is hard. But I have faith because every single human I've talked to understands the importance and the value and the power of graph structured data.
But then you have these legacy systems and investments into these relational and NoSQL systems that where a lot of these connections are somewhat encoded. So there should be a way to just automatically transform that data into the shape that you're describing, right?
Yeah, and you're honestly describing my if I had unlimited resources, what I would build. And there's been some very fascinating POCs I've seen before, where you essentially have the database schema pulled up, say like in a Lucid chart or in some type of visual GUI. And by connecting together the tables just literally in your drawing and indicating what the keys are that connect it, being able to essentially persist that as the structure in your data is the way to make it super easy. You infer your database structure, you say what you want everything to link back together, and you store it back. And that would be the start of how we make graph structures evolve from tables. Very, very, very easy.
So actually, I forgot to ask you this question, so let's close here. So which domains, Denise, do you think are furthest along in terms of graph thinking? Which particular industries or companies or whatever?
If you are in the InfoSec or the security community, this is a structure for you. This is going to be that new way to solve your problem that's going to unblock you from the very complex issue that you're probably investigating in your data. So that would be one of the first domains. It's also probably the first domain that I remember having personally built work in was in security, in the security space. And probably some of the coolest stuff happening in graphs and security we don't get to know about, but I do know that they're pretty fascinating use cases. After that, any type of consumer personalization, which is going to pretty much be industry agnostic. If you have a consumer-facing app and you need to make a personalized experience, regardless of your industry, that's going to be a place to apply this type of technology. And one you already mentioned, the last one, is within your industry when you need to start to flag malicious behavior or fraudulent behavior, maybe more related to the security community, but still needing to understand within e-commerce what is a fraudulent behavior or any other type of specific application. A lot of insurance work as well as using graph structures for fraud. Those are the main ones that I see as big applications for graph data, but they're mainly horizontal across all industries, security, personalization, and fraud, than just within one silo of e-commerce or et cetera.
As you were talking, I don't know why I started thinking of cryptocurrencies.
It's
do they use graphs?
There's a fascinating intersection between graph technology and cryptocurrencies with homomorphic encryption.
Oh, okay.
And the Mimblewimble. I am serious. This is called Mimblewimble. It's a Mimblewimble encryption algorithm. It's a homomorphic encryption algorithm. And there's a very, very fascinating way to kind of dovetail an intersection between cryptocurrency, encryption strategies, and graph technology within that small space. And just for a fun fact, the Mimblewimble community, it's an anonymous community that all uses Harry Potter names as their screen names because Mimblewimble is a spell from the Harry Potter books. So
let me guess, it's super slow.
Oh, the actual application?
Yeah.
Yes, but it's for security. Right. You're going to sacrifice speed for safety. So.
Right. So what is the biggest? So last question. So what is the biggest graph that you've encountered? Let's say at DataStax or even outside.
And So when you talk about large graphs, I immediately go to say like number of instances it requires up in like AWS to host it. And I think right now I've got 5 different regions in the world across hundreds of machines.
Wow. Wow.
So it is the core for a major logistics company around the world. They use graph technology across 5 regions in the world in order to track the real-time status of any package to any person and delivery date.
Wow. Wow. Awesome. And with that, thank you, Denise Gosnell.
Thank you, Ben, so much for having me here. This was fun.